Welcome to Scaling New Heights, a program by engineers for engineers. We'll take you behind the scenes and provide a small glimpse of what it takes to create the software and services that make our modern world possible. As you'll learn, the problems aren't just technical, they're also human. Each executive on our program is a member of the ENG community. ENG stands for Engage, Network, Grow, and it's a peer network of more than 200 top technical executives at leading SaaS companies. They're each on a personal and professional journey to scale to new heights. Joining us today is Anthony Johnson. Anthony was most recently principal engineer and architect in charge of cloud services at Ellie. He was implementing what the business needs for cloud, and it was his responsibility to close the gaps. But he's recently joined Scalar as our field CTO. And his job is to bring the knowledge that he has from the last 20 years of trying to build event data clouds and observability systems to the benefit of our customers. Anthony, welcome to Scaling New Heights.
Thank you. Glad to be here.
So start with just why you made the decision to join Scalar.
Sure. It's a great question because, I mean, we're in the middle of a pandemic and you look around and, you know, our friends are losing their jobs, and why on earth would I leave a company where it's actually, you know, finances, you know, Ellie does finance work, and people are buying more houses and refinancing today. So there was definitely, I had job security. So why leave? I think it had to do with what I was doing at Ellie and what Scalar was doing. And basically, I built off of existing technologies, built on Elasticsearch, you know, built what I thought was going to be the most extremely scalable, best for the business. And then I looked at what I built and I realized, I'm like, did I really do the business a great service? And I looked at where Scalar was at, and I looked at where I needed Scalar to be. And I'm like, you know, they're going the right direction, you know, and I think if I join, I can actually, you know, give back to sort of the greater industry of you know, help deliver solutions that the industry needs, just with some better insights in there. And like I said, my goal is hopefully Ellie Mae long-term will be using Scalar technologies. That's my hope and dream. So that's kind of why I ended up here today is, you know, fun challenges, wanted to get there.
Love it. Well, we are delighted to have you. And this is kind of your first opportunity to pay it forward. You have 3 different times you have built essentially the event data cloud and the observability platform for your company. Take us through that journey. Like, what did you do? What was your original vision? And then let's start to dig into what was hard about it.
Sure. I mean, there's, you know, I mean, many people have built this sort of system of record of statistics, and mine have been from different perspectives all along the way. And so I think, you know, if I go back about 10, 15 years, there was a messaging system that I helped support and run that supported government, like senators and their aides, all communicating back and forth for legislation and coordination. And this was an AT&T BlackBerry sort of service that they offered. And it was a huge Java platform, and, you know, these logs were very valuable. And so at the time, you know, I looked at them, I go, well, we didn't really, you know, we had sort of a Splunk kind of thing, but what we really needed was statistics from these. And so I, you know, over a July 4th weekend, I had an epiphany. I'm like, hey, why am I not scraping these and building metrics off of them? And that's what I did. I you know, wrote I wrote a little C program because this was very mission critical. Can't go put a lot of things that use CPU on there, deployed it out, it auto updated, did all sorts of crazy things, and eventually emitted metrics that ended up into an RRD database, round robin database, which is sort of a kind of a, you know, where we, you know, which is storing event data, event metrics, time series metrics. And we visualize these with cacti and, you know, not quite, you know, it's not quite logs at this time. There was syslog server, of course, but getting at those metrics of the logs was very valuable. And so we built this system, you know, we used it to be able to fix outages. But ultimately, at the end of the day, it was a proprietary system of code I wrote that, you know, none of the other guys I worked with could even, you know, could barely spell C. So at the end of the day, you know, I'm sure that that product ultimately went away, got bought by another company, but that was, you know, didn't really make the cut. So fast forward, I'll just use more recent experiences because I think those are fun. At Ellie Mae, I built two systems built off of Elasticsearch. One was, going with Amazon Elasticsearch service. And this sort of, hey, I'm going to pay somebody else to run Elasticsearch for me. And, we emitted, this was specifically a logging platform. We emitted logs to it. We wrote connectors with Lambda to be able to get logs in there. You could write directly to it. And the system worked great until it didn't work great. And this is, we had scaling challenges with AWS Elasticsearch service. There were limits on how many nodes we could have. There were limits on the URL I could present to my users, and they've solved a lot of these problems today. But again, I'm limited by my vendor on a lot of these, and especially if that vendor is wrapping another vendor. And so at the end of it, we could only keep 3 days online by the end of that product, and we pivoted to a build your own Elasticsearch cluster licensed from Elastic. But at the time it took us to build that our own sort of on-prem, I mean, it was months and months and months. And the business got, was like, when is it going to be delivered? When is it going to be delivered? We're tired. We want more than 3 or 4 days of data. And like I said, it was a lot. It was pretty tedious. We built it, it was successful and it ran great until it didn't run great. And so we were at around 2 terabytes a day, probably about 50 to 60 data nodes. We really started running into a lot of problems with cluster management, problems with data latency coming into the system. And ultimately it's, the business, Ellie Mae's business was not running Elasticsearch. At the end of the day, they wanted to refinance.
Right. Right.
Yeah.
So dig into that a little bit. Like ultimately, like you say, you were able to build a successful service, but it took a lot of effort to do that, and you ran into some roadblocks. Pick 2 or 3 just of the biggest challenges that if you're going to go down this path, what is it that you should be prepared for from a cost, from a scalability, from a challenge perspective, complexity, whatever?
Well, so let me start off with, in hindsight, I honestly don't consider it delivered. It took in 4 terabytes of data a day with some tender loving care it would support, but I don't consider it a success. And the reason I don't consider it a success is really the first challenge, which is continuity of the thing. Because people have smart engineers come in. Those smart engineers like myself and, Ellie Mae actually called them clever engineers or clever troublemakers. And the reality is that a smart engineer if not everybody has the ability to work at Google. Google has tons of the best engineers. Amazon has tons of the best engineers. And that's not to say that Ellie Mae's engineers are bad. It's just that they want to do, finance related work, not, orchestrating observability. So the system I built, I have very low confidence that they're really going to be able to support it long term. The reality is that I built a system that worked, and as long as I was there, it would be great. And if the company was going to fund it with 3 or 4 individuals, it'd have been highly successful. But it's a distraction for the business. It's not their business use case. So I think that's one of the biggest challenges is continuity. I think beyond there, I think especially with Elasticsearch, Kibana can be a bit daunting. It's a great product. There is a lot to take in. And, training was definitely an issue. The pivot from Splunk, because we did migrate from Splunk to Kibana, there were a lot of shortcomings with how you query. So I definitely, and a lot of disappointed users when they were like, well, in Splunk, I could just on the fly do this and this and this and this and derive this. And Kibana's not that way. You have to be much more upfront with your data, which luckily for Scalar, where we have Power Query that supports a lot of these features that Kibana and Elasticsearch can't. And I think third, if I'm looking for a big one, I really think getting data. Well, let's talk about indexing. The strategy here is, not one index to rule them all, but every team gets an index, or they get a subset of indexes. We want them to be logically grouped to an application. Getting teams to adhere to a consistent schema, I think, was impossible. And so when you're fluid with your schema, it's not a great thing for Elasticsearch. You start ending up with data loss. You start ending up with queries to the system not working because shards are incompatible between indexes. And so I think a lot of those challenges where it's just did not work the way expected, or because our users are fluid, the schema wasn't, and the engine behind it, it was expecting everything to just be a little too perfect. I'd say those are my big three.
So Scalar doesn't use indexing, and so I don't understand a lot about it, but I hear often talking with people like you and other customers that indexing itself has some really positive sides, and then it has its own limitations or downsides. Can you just highlight 2, 3, 4 things that you think stand out as some of the problems with indexing if you're working with high cardinality data sets?
I mean, I will give you the insights that I've learned over time. And so I first off, I think we say Scalar doesn't index. I honestly think Scalar does index, but we don't index in the most popular way, which is the inverted index. And so for most people, they're like, what is inverted index? It's simply think about your index at the end of your favorite bird watching book. You go to the very end, and there's if you want to learn about cardinals, you learn about it on page 50, 53, and 74. And because you see it on page 50 and 53, there's some you can see some frequency there, and you know what, you should probably focus your energies there. That's probably where cardinals are the most important, or robins, whichever one I mentioned. And so so logically grouping the data and knowing where the data is by keyword, I think is an important way to do it. And the way that Elasticsearch accomplishes it is really sort of, let's tokenize all the data. Let's throw out common words like is and the and these, because that would hit every document and it's pointless. And then let's keep here is the documents where all these keywords are found. So that's sort of the principles of it. I mean, the reality is that the advantage of indexing, of course, is that, you put in a term, you don't have to search across all of your documents. You put in a term, it's in document 5, 7, and 3. You go pull up 5, 7, and 3. You can instantly tell the user, because you're just doing a length on an array, because it's literally just sort of, this field is in these documents. You can do a length and say, oh, it's in 3 documents. You give them the first 3 documents and they're happy. The challenge comes is what happens when there's, what happens when you have a field that is changing very rapidly, and let's say, or is always unique, then all of a sudden you throw in 1 billion records. Now in that field, you have a list of 1 billion items. And so it really doesn't add that much value. In fact, it can, be detrimental to trying to do any sort of, and this, and in an indexed world is really just, oh, let me take this field and let me take this field and merge them together. That's our total documents we're bringing in there. And there's, they start
working. So is it an agility problem? Like what?
It's a scalability problem at the end of the day, because indexes can grow exponentially. And the way that Elastic says, oh, well, you need to go influence the indexer to reduce the index size. That's how you scale. And I'm, as an end user, as a consumer of Elasticsearch, I'm like, I don't want to waste my time doing that. I have better things to do. Why are you not smart enough? Why are you not smart enough to know how to do this for me? Or just forget about it. Let me just tell you on the fly what I want, and you can just go figure it out. And so I started very much on a schema on write sort of camp, where let's have the world entirely perfect and let's write it out. At the end of the day, I'm much more in the schema on read now, because the world's not perfect. Nobody understands the questions up front, and nobody understands the value of data, or they want to, or invest the time until they need until they want to ask the question. So I've kind of drifted back. And so really the question it really is, and I was lucky enough to see one of Steve's topics, is can you do that schema on read fast enough so that you don't annoy your users? Nobody wants to wait. And so that's really, to make it work at scale, you've got to be able to execute queries as fast as possible. Users are impatient.
So what is, you talk about scale, are there 4 or 5 signs that you've kind of outgrown Elasticsearch?
I mean, I think they're the same signs that you would hit just about any scalable platform. Just about every successful logging service, observability, telemetry, any sort of they have buffers throughout the system. So if you're, Kafka is one of these popular buffers. SQS, maybe holding S3 events is another popular buffer. Just writing to disk, Logstash can write to disk as an example. And so, but if those buffers start backing up, and your users start complaining about latency, well, hey, I wrote this message, I haven't seen it in an hour. Or if you're in a really bad shape, I haven't seen it in a day or 8 hours, then, probably you're dealing with some scalability challenges. I think if you're doing local optimizations to meet, to sort of solve these problems, I think is another issue where, you're like, well, if I turn this knob right here, I can get 10% more, 10% more out of it. And the reason that people are not just adding more nodes is because the business cares about cost. And so if you're going to just keep, if you're continuously just keep adding nodes, that's a sign that you've outgrown it. And honestly, the biggest issue that I ran into was index and shard growth, where, I just felt like I'm going to have to make this work. I'm going to have to go in here and write a whole bunch of scripting around this thing to be able to meet their limitations. Not because there's anything I did wrong. It's just that their system can't handle it. And so you start hitting those with too many shards, and they'll tell you, well, you can't have shards over 50 gigs in size. And it's like, well, the reason that is because they manage moving this data across their entire system, and it just makes it too long. And so, these network challenges, these ingest challenges, they're all kind of the same problem of just Elasticsearch's scalability hits its limits and the architecture hits its limits, and it becomes painful.
So looking back, is there one key lesson or something you would do differently?
For me, at the end of the day, I think my, you could call it my ego, my hubris, whatever you want to call it. Smart engineers need to be careful, because a smart engineer always wants an engineering challenge and always wants to show off how they've done the impossible, or they've done something. And so at Ellie Mae, the impossible was they were a Splunk shop, paying a lot of money. And I said, well, gee, I'll go and build you a system. And I think this happens with a lot of engineers where they're just like, you know what, this is not that hard. And it truly wasn't that hard to do. The challenge is that now you've signed up that business to own that thing long term. And let's be honest, if you build an observability platform, the company wants to use that for 3, 5, a decade if possible. That's where they get their return on their investment, and they want it to be the right decision. And so I think the challenge that I ran into is I sat here and I said, wow, let's go do Elasticsearch. It's great technology. It gives us vision. But at the end of the day, the reality was it probably should have not happened, and I don't think this is a lack of due diligence. I think it's more of, I anchored myself towards a particular vendor because it was the engineering challenge at the time. Having it done for you is probably the right choice. Even if it costs more, it's probably the right choice. The advantage we have is that Scalar typically costs less, which is an awesome problem to have.
Yeah, exactly. Well, there's a lot more that we can learn from you and will, but before we close this session of Scaling New Heights, I want to go through a quick lightning round with you. Are you ready?
Sure.
What's your favorite ice cream?
My favorite ice cream is Chunky Monkey by Ben & Jerry's.
That's good. Star Trek or Star Wars?
Definitely Star Wars, but only the original 3.
Okay, good answer. What's your least favorite food?
Least favorite food? There's a food in Japan called natto, which is fermented soybeans. And my wife being Japanese and my kids being a little bit of, American and Japanese, they love it. And it's stinky.
What is the first place you're traveling once shelter in place is over, completely over?
Probably to see my brother and my mother in Jacksonville.
Awesome. And is there any TV show that you're binging right now?
My kids and I are binging an anime called One Piece on Netflix. And I go in and out of it because it's a typical Dragon Ball Z where, tough villain, they got to build up their strength. They face them, and they win. And it's like 4 or 5 episodes, but I catch up on the 5th episode so I can just skip all of the drama.
Perfect. All right. Our final question is, what is the biggest or scariest thing you have ever personally scaled?
Scariest thing I have personally scaled, honestly, the Elasticsearch that Because the challenge is, and I think this plays out a lot, is that you know, when you're that when you're that center service person, whenever you make a mistake, it can be felt for days or, you know, weeks afterwards. And so, you know, so that you know, so, you know, moving data around, you know, data loss, all of it comes into play. And with large databases, you know, recovery can take, you know, can take 12 hours to you know, can take days. And so that to me in my career was the scariest thing that I have done at scale, which is honestly, you know, amazing story to hear from me as well, that that's the problem we're trying to solve for people.
Yep, exactly, which is why you're in exactly the right place. Anthony, thank you for joining us on Scaling New Heights. It was a pleasure to have you.
Thank you. I appreciate it. You guys take care.
If you want to hear more stories or learn about Eng and how to become a member of the community, visit scalar.com. That's SCALYR.com. Thank you.